Welcome to the channel Next Gen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Data Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
One of your encryption keys stored in Cloud Key Management Service, Cloud KMS, was exposed. You need to re-encrypt all of your CMEK-protected cloud storage data that used that key, and then delete the compromised key. You also want to reduce the risk of objects getting written without Customer-Managed Encryption Key, CMEK, protection in the future. What should you do? The options are: Option A, rotate the Cloud KMS key version. Continue to use the same cloud storage bucket. Option B, create a new Cloud KMS key. Set the default CMEK key on the existing cloud storage bucket to the new one. Option C, create a new Cloud KMS key. Create a new cloud storage bucket. Copy all objects from the old bucket to the new one bucket while specifying the new Cloud KMS key in the copy command. Option D, create a new Cloud KMS key. Create a new cloud storage bucket configured to use the new key as the default CMEK key. Copy all objects from the old bucket to the new bucket without specifying a key.
To arrive at the correct answer, we focus on the keywords: encryption keys stored in Cloud Key Management Service, Cloud KMS, was exposed, re-encrypt all of your CMEK-protected cloud storage data, reduce the risk of objects getting written without Customer-Managed Encryption Key, CMEK, protection.
The correct answer is option D, create a new Cloud KMS key. Create a new cloud storage bucket configured to use the new key as the default CMEK key. Copy all objects from the old bucket to the new bucket without specifying a key.
Why is this correct? D. Creating a new bucket with a default CMEK key ensures all future objects are encrypted, reducing risk. Copying data to this bucket without specifying a key automatically re-encrypts the existing objects using the new default key. Why are the others incorrect? A. Rotating the key version doesn't automatically re-encrypt existing data. Additionally, continuing to use the same bucket without setting a default CMEK key doesn't mitigate the risk of objects being written without encryption in the future. B. While setting a default CMEK key helps with future objects, it does not automatically re-encrypt existing data already present in the bucket that was encrypted with the compromised key. C. While this re-encrypts existing data, it fails to set a default CMEK key on the new bucket. This leaves the new bucket vulnerable to future objects being written without CMEK protection.
You have an upstream process that writes data to cloud storage. This data is then read by an Apache Spark job that runs on Dataproc. These jobs are run in the US Central 1 region, but the data could be stored anywhere in the United States. You need to have a recovery process in place in case of a catastrophic single region failure. You need an approach with a maximum of 15 minutes of data loss, RPO equals 15 minutes. You want to ensure that there is minimal latency when reading the data. What should you do? The options are: Option A, 1. Create 2 regional cloud storage buckets, one in the US Central 1 region and one in the US South 1 region. Point 2. Have the upstream process write data to the US Central 1 bucket. Use the storage transfer service to copy data hourly from the US Central 1 bucket to the US South 1 bucket. Point 3. Run the Dataproc cluster in a zone in the US Central 1 region, reading from the bucket in that region. Point 4. In case of regional failure, redeploy your Dataproc clusters to the US South 1 region and read from the bucket in that region instead. Option B, 1. Create a cloud storage bucket in the US multi-region. Point 2. Run the Dataproc cluster in a zone in the US Central 1 region, reading data from the US multi-region bucket. Point 3. In case of a regional failure, redeploy the Dataproc cluster to the US Central 2 region and continue reading from the same bucket. And the remaining options are option C, 1. Create a dual-region cloud storage bucket in the US Central 1 and US South 1 regions. Point 2. Enable turbo replication. Point 3. Run the Dataproc cluster in a zone in the US Central 1 region, reading from the bucket in the US South 1 region. Point 4. In case of a regional failure, redeploy your Dataproc cluster to the US South 1 region and continue reading from the same bucket. Option D, 1. Create a dual-region cloud storage bucket in the US Central 1 and US South 1 regions. Point 2. Enable turbo replication. Point 3. Run the Dataproc cluster in a zone in the US Central 1 region, reading from the bucket in the same region. Point 4. In case of a regional failure, redeploy the Dataproc clusters to the US South 1 region and read from the same bucket.
To arrive at the correct answer, we focus on the keywords: a Central 1 region, catastrophic single region failure, maximum of 15 minutes of data loss, RPO equals 15 minutes, minimal latency when reading the data.
Review the options on screen. The correct answer is option D, 1. Create a dual-region cloud storage bucket in the US Central 1 and US South 1 regions. Point 2. Enable turbo replication. Point 3. Run the Dataproc cluster in a zone in the US Central 1 region, reading from the bucket in the same region. Point 4. In case of a regional failure, redeploy the Dataproc clusters to the US South 1 region and read from the same bucket.
Why is this correct? D. A dual-region bucket with turbo replication guarantees an RPO of 15 minutes. Running the cluster in the same region as the data, US Central 1, minimizes read latency. Upon failure, redeploying the cluster to the secondary region maintains access. Why are the others incorrect? A. Using storage transfer service to copy data hourly results in an RPO of 60 minutes, which fails to meet the strict 15-minute RPO requirement. B. A multi-region bucket does not support turbo replication, meaning it cannot guarantee a 15-minute RPO. It may also introduce higher latency compared to dual-region storage. C. Reading from a bucket in a different region, a South 1, while the cluster is in a Central 1 introduces cross-region network latency, violating the minimal latency requirement.
You currently have transactional data stored on-premises in a PostgreSQL database. To modernize your data environment, you want to run transactional workloads and support analytics needs with a single database. You need to move to Google Cloud without changing database management systems and minimize cost and complexity. What should you do? The options are: Option A, migrate and modernize your database with Cloud Spanner. Option B, migrate your workloads to AlloyDB for PostgreSQL. Option C, migrate to BigQuery to optimize analytics. Option D, migrate your PostgreSQL database to Cloud SQL for PostgreSQL.
To arrive at the correct answer, we focus on the keywords: PostgreSQL database, run transactional workloads and support analytics needs with a single database, without changing database management systems.
The correct answer is option B, migrate your workloads to AlloyDB for PostgreSQL.
Why is this correct? B. AlloyDB for PostgreSQL is a fully managed, PostgreSQL-compatible database service optimized for both demanding transactional, OLTP, and analytical, OLAP, workloads in a single database, meeting all requirements. Why are the others incorrect? A. Cloud Spanner is not PostgreSQL. Migrating to Spanner violates the requirement of not changing the database management system. C. BigQuery is an enterprise data warehouse designed for analytics, not transactional workloads. It requires changing the database system. D. While Cloud SQL for PostgreSQL is a managed PostgreSQL service, it is primarily for transactional workloads and not natively optimized for supporting analytical needs simultaneously like AlloyDB.
You are architecting a data transformation solution for BigQuery. Your developers are proficient with SQL and want to use the ELT development technique. In addition, your developers need an intuitive coding environment and the ability to manage SQL as code. You need to identify a solution for your developers to build these pipelines. What should you do? The options are Option A, use Dataform to build, manage, and schedule SQL pipelines. Option B, use Dataflow jobs to read data from pub/sub, transform the data, and load the data to BigQuery. Option C, use Data Fusion to build and execute ETL pipelines. Option D, use Cloud Composer to load data and run SQL pipelines by using the BigQuery job operators.
To arrive at the correct answer, we focus on the keywords: data transformation solution for BigQuery, proficient with SQL, ELT development technique, intuitive coding environment, manage SQL as code.
The correct answer is option A, use Dataform to build, manage, and schedule SQL pipelines.
Why is this correct? A. Dataform is designed specifically for BigQuery data transformations using the ELT technique. It provides an intuitive coding environment and enables developers to manage SQL as code seamlessly. Why are the others incorrect? B. Dataflow relies on Apache Beam rather than SQL as code. It is designed for complex streaming or batch ETL pipelines, not for developers focusing on SQL-based ELT. C. Data Fusion is a visual, GUI-based ETL tool. It does not provide the requested intuitive coding environment for developers to manage SQL as code. D. A Cloud Composer orchestrates workflows using Python DAGs. It does not offer a native, intuitive coding environment specifically designed for developing and managing SQL as code.
You work for a farming company. You have one BigQuery table named Sensors, which is about 500 megabytes and contains the list of your 5,000 sensors, with columns for ID, name, and location. This table is updated every hour. Each sensor generates one metric every 30 seconds along with a timestamp, which you want to store in BigQuery. You want to run an analytical query on the data once a week for monitoring purposes. You also want to minimize costs. What data model should you use? The options are Option A, 1. Create a metrics column in the sensors table. Point 2. Set record type and repeated mode for the metrics column. Point 3. Use an update statement every 30 seconds to add new metrics. Option B, 1. Create a metrics column in the sensors table. Point 2. Set record type and repeated mode for the metrics column. Point 3. Use an insert statement every 30 seconds to add new metrics. Option C, 1. Create a metrics table partitioned by timestamp. Point 2. Create a sensor ID column in the metrics table that points to the ID column in the sensors table. Point 3. Use an insert statement every 30 seconds to append new metrics to the metrics table. Point 4. Join the two tables, if needed, when running the analytical query. Option D, 1. Create a metrics table partitioned by timestamp. Point 2. Create a sensor ID column in the metrics table, which points to the ID column in the sensors table. Point 3. Use an update statement every 30 seconds to append new metrics to the metrics table. Point 4. Join the two tables, if needed, when running the analytical query.
To arrive at the correct answer, we focus on the keywords: BigQuery table named Sensors, updated every hour, generates one metric every 30 seconds, analytical query, once a week, minimize costs.
The correct answer is option C, 1. Create a metrics table partitioned by timestamp. Point 2. Create a sensor ID column in the metrics table that points to the ID column in the sensors table. Point 3. Use an insert statement every 30 seconds to append new metrics to the metrics table. Point 4. Join the two tables, if needed, when running the analytical query.
Why is this correct? C. Separating high-frequency time series data into a partition table allows efficient append-only streaming inserts and minimizes scan costs for analytical queries by joining with the dimension table when needed. Why are the others incorrect? A. BigQuery imposes strict quotas on DML update statements per table. Running an update every 30 seconds will quickly exceed these limits. B. You cannot simply use an insert statement to append to a repeated field in an existing row. Doing so would require an update, which is subject to DML quotas, or inserting duplicate sensor rows. D. Using an update statement to append metrics every 30 seconds is an anti-pattern for time series data and will violate BigQuery's strict DML quotas.
You are managing a Dataplex environment with raw and curated zones. A data engineering team is uploading JSON and CSV files to a bucket asset in the curated zone, but the files are not being automatically discovered by Dataplex. What should you do to ensure that the files are discovered by Dataplex? The options are: Option A, move the JSON and CSV files to the raw zone. Option B, enable auto-discovery of files for the curated zone. Option C, use the BG command line tool to load the JSON and CSV files into BigQuery tables. Option D, grant object-level access to the CSV and JSON files in cloud storage.
To arrive at the correct answer, we focus on the keywords, raw and curated zones, curated zone, JSON and CSV files, not being automatically discovered.
The correct answer is option A, move the JSON and CSV files to the raw zone.
Why is this correct? A. In Dataplex, raw zones support any data format, including JSON and CSV, for automatic discovery. Curated zones are restricted to analytical formats like Parquet, Avro, or ORC. Why are the others incorrect? B. Auto-discovery in curated zones enforces supported analytical file formats. It will not discover unsupported formats like JSON and CSV. C. Loading files into BigQuery bypasses Dataplex data discovery rather than ensuring the files are discovered by Dataplex in its storage zones. D. The failure to discover files is due to the curated zones format restrictions, not a lack of object-level access in cloud storage.
You have a table that contains millions of rows of sales data, partitioned by date. Various applications and users query this data many times a minute. The query requires aggregating values by using AVG, MAX, and SUM, and does not require joining to other tables. The required aggregations are only computed over the past year of data, though you need to retain full historical data in the base tables. You want to ensure that the query results always include the latest data from the tables, while also reducing computation cost, maintenance overhead, and duration. What should you do? The options are: Option A, create a materialized view to aggregate the base table data. Include a filter clause to specify the last 1 year of partitions. Option B, create a materialized view to aggregate the base table data. Configure a partition expiration on the base table to retain only the last 1 year of partitions. Option C, create a view to aggregate the base table data. Include a filter clause to specify the last year of partitions. Option D, create a new table that aggregates the base table data. Include a filter clause to specify the last year of partitions. Set up a scheduled query to recreate the new table every hour.
To arrive at the correct answer, we focus on the keywords, query requires aggregating values, only computed over the past year of data, retain full historical data in the base tables, always include the latest data, reducing computation cost, maintenance overhead, and duration.
The correct answer is option A, create a materialized view to aggregate the base table data. Include a filter clause to specify the last 1 year of partitions.
Why is this correct? A. Materialized views pre-compute aggregations to reduce computation cost and duration. By filtering for the last 1 year, it meets the temporal requirement without deleting historical data. It updates automatically to include the latest data, minimizing maintenance overhead. Why are the others incorrect? B. Configuring partition expiration on the base table would delete data older than 1 year, directly violating the explicit requirement to retain full historical data in the base tables. C. A standard logical view executes the underlying query every time it is accessed. For frequent queries on millions of rows, this fails to reduce computation cost or duration compared to a materialized view. Why are the others incorrect? D. Relying on a scheduled query to populate a new table introduces maintenance overhead and only provides data as fresh as the last hourly run, failing the requirement to always include the latest data.
Your organization uses a multi-cloud data storage strategy, storing data in cloud storage and data in Amazon Web Services, AWS, S3 storage buckets. All data resides in US regions. You want to query up-to-date data by using BigQuery, regardless of which cloud the data is stored in. You need to allow users to query the tables from BigQuery without giving direct access to the data in the storage buckets. What should you do? The options are: Option A, set up a BigQuery Omni connection to the AWS S3 bucket data. Create big lake tables over the cloud storage and S3 data and query the data using BigQuery directly. Option B, set up a BigQuery Omni connection to the AWS S3 bucket data. Create external tables over the cloud storage and S3 data and query the data using BigQuery directly. Option C, use the storage transfer service to copy data from the AWS S3 buckets to cloud storage buckets. Create big lake tables over the cloud storage data and query the data using BigQuery directly. Option D, use the storage transfer service to copy data from the AWS S3 buckets to cloud storage buckets. Create external tables over the cloud storage data and query the data using BigQuery directly.
To arrive at the correct answer, we focus on the keywords, storing data in cloud storage, and data in Amazon Web Services, AWS, S3 storage buckets, query up-to-date data by using BigQuery, regardless of which cloud the data is stored in, allow users to query the tables from BigQuery without giving direct access to the data in the storage buckets.
The correct answer is Option A, set up a BigQuery Omni connection to the AWS S3 bucket data. Create big lake tables over the cloud storage and S3 data and query the data using BigQuery directly.
Why is this correct? A. BigQuery Omni enables querying AWS S3 data in place. Big lake tables allow access delegation, meaning users can query the BigQuery tables without needing direct read permissions on the underlying storage buckets. Why are the others incorrect? B. BigQuery external tables require the user to have direct read access to the underlying storage buckets to run queries, which violates the access restriction requirement. C. Using storage transfer service copies data to Google Cloud, adding latency and overhead, which contradicts the goal to query up-to-date data regardless of which cloud it resides in. D. Storage transfer service involves unnecessary data duplication. Additionally, standard external tables require users to have direct access to the underlying storage buckets, violating the security requirement.
You are preparing an organization-wide dataset. You need to pre-process customer data stored in a restricted bucket in cloud storage. The data will be used to create consumer analyses. You need to comply with data privacy requirements. What should you do? The options are: Option A, use Dataflow and the Cloud Data Loss Prevention API to mask sensitive data. Write the process data in BigQuery. Option B, use Customer-Managed Encryption Keys, CMEK, to directly encrypt the data in cloud storage. Use federated queries from BigQuery. Share the encryption key by following the principle of least privilege. Option C, use the Cloud Data Loss Prevention API and Dataflow to detect and remove sensitive fields from the data in cloud storage. Write the filtered data in BigQuery. Option D, use Dataflow and Cloud KMS to encrypt sensitive fields and write the encrypted data in BigQuery. Share the encryption key by following the principle of least privilege.
To arrive at the correct answer, we focus on the keywords, pre-process customer data, cloud storage, comply with data privacy requirements.
The correct answer is Option A, use Dataflow and the Cloud Data Loss Prevention API to mask sensitive data. Write the process data in BigQuery.
Why is this correct? A. Cloud Data Loss Prevention, DLP, API is the standard tool for detecting and masking sensitive data. Dataflow is ideal for processing this data from cloud storage to BigQuery, satisfying privacy requirements while allowing analysis. Why are the others incorrect? B. Encrypting the dataset with CMYK doesn't satisfy privacy requirements for analysis, as users would need to decrypt the sensitive data to analyze it, exposing PII. C. Removing sensitive fields entirely can destroy the analytical value of the dataset. Masking data via the DLP API is the recommended approach to preserve utility while maintaining privacy. D. Cloud KMS is used for managing encryption keys, not for inspecting and encrypting specific sensitive fields within data streams. DLP is explicitly designed for detecting and protecting sensitive data.
You need to connect multiple applications with dynamic public IP addresses to a Cloud SQL instance. You configured users with strong passwords and enforced the SSL connection to your Cloud SQL instance. You want to use Cloud SQL public IP and ensure that you have secured connections. What should you do? The options are: Option A, add CIDR 0.0.0.0/0 network to authorized network. Use Identity and Access Management (IAM) to add users. Option B, add all application networks to authorized network and regularly update them. Option C, leave the authorized network empty. Use Cloud SQL Auth proxy on all applications. Option D, add CIDR 0.0.0.0/0 network to authorized network. Use Cloud SQL Auth proxy on all applications.
To arrive at the correct answer, we focus on the keywords: multiple applications with dynamic public IP addresses, Cloud SQL instance, use Cloud SQL public IP, secured connections.
The correct answer is option C, leave the authorized network empty. Use Cloud SQL Auth proxy on all applications.
Why is this correct? C. Cloud SQL Auth proxy allows secure access without needing to allow list dynamic IPs in authorized networks. It automatically encrypts traffic and securely authenticates connections, meeting all requirements without exposing the instance to the internet. Why are the others incorrect? A. Adding 0.0.0.0/0 exposes the database to the entire internet, severely compromising security. IAM alone does not solve the network-level vulnerabilities created by opening all IPs. B. Regularly updating authorized networks for dynamic IP addresses is operationally difficult, highly error-prone, and does not scale well with multiple applications changing IPs frequently. D. While using Cloud SQL Auth proxy is correct, adding 0.0.0.0/0 to the authorized network unnecessarily exposes the instance to the public internet, violating security best practices.
You are migrating a large number of files from a public HTTPS endpoint to cloud storage. The files are protected from unauthorized access using signed URLs. You created a TSV file that contains the list of object URLs and started a transfer job by using Storage Transfer Service. You notice that the job has run for a long time and eventually failed. Checking the logs of the transfer job reveals that the job was running fine until one point, and then it failed due to HTTP 403 errors on the remaining files. You verified that there were no changes to the source system. You need to fix the problem to resume the migration process. What should you do? The options are: Option A, set up Cloud Storage Fuse and mount the Cloud Storage bucket on a Compute Engine instance. Remove the completed files from the TSV file. Use a shell script to iterate through the TSV file and download the remaining URLs to the Fuse mount point. Option B, renew the TLS certificate of the HTTPS endpoint. Remove the completed files from the TSV file and rerun the Storage Transfer Service job. Option C, create a new TSV file for the remaining files by generating signed URLs with a longer validity period. Split the TSV file into multiple smaller files and submit them as separate Storage Transfer Service jobs in parallel. Option D, update the file checksums in the TSV file from using MD5 to SHA-256. Remove the completed files from the TSV file and rerun the storage transfer service job.
To arrive at the correct answer, we focus on the keywords, signed URLs, run for a long time, HTTP 403 errors.
The correct answer is option C. Create a new TSV file for the remaining files by generating signed URLs with a longer validity period. Split the TSV file into multiple smaller files and submit them as separate storage transfer service jobs in parallel.
Why is this correct? C. HTTP 403 errors on signed URLs after a long time indicate the URLs expired. Generating new signed URLs with a longer validity period and splitting the transfer into smaller, parallel jobs ensures the transfer completes before they expire. Why are the others incorrect? A. Using a fuse mount and a shell script to download files is a custom, less reliable, and slower approach compared to utilizing the native, fully managed storage transfer service. B. The 403 errors are due to expired signed URLs, not an issue with the TLS certificate. Renewing the TLS certificate does not address the URL expiration. D. Updating file checksums from MD5 to SHA-256 does not resolve HTTP 403 access denied errors caused by expired signed URLs.
You work for an airline and you need to store weather data in a BigQuery table. Weather data will be used as input to a machine learning model. The model only uses the last 30 days of weather data. You want to avoid storing unnecessary data and minimize costs. What should you do? The options are: Option A, create a BigQuery table where each record has an ingestion timestamp. Run a scheduled query to delete all the rows with an ingestion timestamp older than 30 days. Option B, create a BigQuery table partitioned by date-time value of the weather date. Set up partition expiration to 30 days. Option C, create a BigQuery table partitioned by ingestion time. Set up partition expiration to 30 days. Option D, create a BigQuery table with a date-time column for the day the weather data refers to. Run a scheduled query to delete rows with a date-time value older than 30 days.
To arrive at the correct answer, we focus on the keywords, store weather data in a BigQuery table, only uses the last 30 days of weather data, avoid storing unnecessary data, minimize costs.
The correct answer is option B. Create a BigQuery table partitioned by date-time value of the weather date. Set up partition expiration to 30 days.
Why is this correct? B. Partitioning by the logical weather date and setting a 30-day partition expiration automatically removes old data with zero additional processing costs, natively meeting all retention and cost minimization requirements. Why are the others incorrect? A. Running scheduled DML queries to delete rows incurs additional compute costs, failing to minimize costs. Also, ingestion time may not accurately reflect the actual logical weather date. C. Partitioning by ingestion time deletes data based on when it was loaded rather than the logical weather date, which could lead to incorrect data retention if ingestion delays occur. D. Executing scheduled queries to delete data based on a date-time column incurs unnecessary query processing costs, making it less cost-effective than native partition expiration.
You need to look at BigQuery data from a specific table multiple times a day. The underlying table you are querying is several petabytes in size, but you want to filter your data and provide simple aggregations to downstream users. You want to run queries faster and get up-to-date insights quicker. What should you do? The options are: Option A, run a scheduled query to pull the necessary data at specific intervals daily. Option B, use a cached query to accelerate time to results. Option C, limit the query columns being pulled in the final result. Option D, create a materialized view based off of the query being run.
To arrive at the correct answer, we focus on the keywords, multiple times a day, several petabytes in size, filter your data and provide simple aggregations, run queries faster and get up-to-date insights quicker.
The correct answer is option D. Create a materialized view based off of the query being run.
Why is this correct? D. Materialized views periodically cache results of a query, offering increased performance and efficiency. They are ideal for repeatedly filtering and aggregating large datasets, ensuring faster execution and up-to-date insights without scanning petabytes of data each time. Why are the others incorrect? A. Scheduled queries run at fixed intervals, so insights won't be continuously up-to-date when queried at arbitrary times throughout the day. B. Query caching only works if the exact same query is executed and the underlying data hasn't changed, making it unreliable for continuously updated up-to-date insights. C. While limiting columns reduces the amount of data scanned, it does not pre-compute simple aggregations or optimally accelerate query performance for petabyte-scale tables like materialized views do.
Your chemical company needs to manually check documentation for customer order. You use a pull subscription in pub/sub so that sales agents get details from the order. You must ensure that you do not process orders twice with different sales agents and that you do not add more complexity to this workflow. What should you do? The options are: Option A, use a deduplicate p-transform in Dataflow before sending the messages to the sales agents. Option B, create a transactional database that monitors the pending messages. Option C, use pub/sub exactly once delivery in your pull subscription. Option D, create a new pub/sub push subscription to monitor the orders processed in the agent's system.
To arrive at the correct answer, we focus on the keywords: pull subscription in pub/sub, do not process orders twice, do not add more complexity.
The correct answer is option C, use pub/sub exactly once delivery in your pull subscription.
Why is this correct? C. Pub/sub's exactly once delivery feature directly addresses the requirement to not process orders twice, preventing duplicates at the subscription level without adding architectural complexity. Why are the others incorrect? A. Adding a Dataflow pipeline introduces significant architectural complexity and operational overhead to the workflow, violating the requirement to not add more complexity. B. Creating and managing a separate transactional database adds unnecessary architectural complexity and maintenance overhead, violating the requirement to keep the workflow simple. D. A push subscription requires an endpoint and does not natively guarantee exactly once delivery without additional custom logic, thereby increasing complexity.
You are migrating your on-premises data warehouse to BigQuery. As part of the migration, you want to facilitate cross-team collaboration to get the most value out of the organization's data. You need to design an architecture that would allow teams within the organization to securely publish, discover, and subscribe to read-only data in a self-service manner. You need to minimize costs while also maximizing data freshness. What should you do? The options are: Option A, use Analytics Hub to facilitate data sharing. Option B, create authorized datasets to publish shared data in the subscribing team's project. Option C, create a new dataset for sharing in each individual team's project. Grant the subscribing team the BigQuery.DataViewer role on the dataset. Option D, use BigQuery Data Transfer Service to copy datasets to a centralized BigQuery project for sharing.
To arrive at the correct answer, we focus on the keywords: securely publish, discover, and subscribe, self-service manner, minimize costs, maximizing data freshness.
The correct answer is option A, use Analytics Hub to facilitate data sharing.
Why is this correct? A. Analytics Hub provides a secure, self-service platform to publish, discover, and subscribe to datasets. It shares data in place without copying, thereby minimizing storage costs and ensuring maximum data freshness. Why are the others incorrect? B. Authorized datasets authorize views to access underlying data without direct permissions but do not provide a self-service platform for discovering and subscribing to data. C. Manually managing datasets and IAM roles lacks self-service discovery and subscription capabilities, making it difficult to scale cross-team collaboration compared to Analytics Hub. D. Copying datasets increases storage costs and introduces latency, which violates the strict requirements to minimize costs and maximize data freshness.